Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of S1 variant 52 of June 2021. For this lecture, I am using the work of one of my best student, Ms. Maharosh Kasbati of class 2022, the Lyceum. Well, all these instructions are very important, especially this last one. Give non-exact numerical answers correct to 3 significant figures. Must follow all these instructions. An important tip, read the questions carefully. Question number 1. An ordinary fair die, fair means probability is same of all the numbers. An ordinary fair die is thrown repeatedly until a 5 is obtained. This information means this question is of geometric distribution. This means geometric distribution with P 1 upon 6. The number of throws taken is denoted by the random variable x. Write down the mean of this. So since distribution is geometric, therefore mean of geometric is 1 upon p. And p is 1 upon 6. So we just need to write reciprocal of this here, which is 6. Part B. Find the probability that a 5 is first obtained after the 3rd throw but before the 8th throw. So between these two throws, like 4, 5, 6, 7. For 4, you should write QQ times P. For 5th throw, you need to write Q4 P power 1, and so on. So this is for 5th throw, this is for 6th throw, and this is for 7th throw. This is the answer up to 3 significant figures. Always give your answer up to 3 significant figures if the answer is non-exact. Part C. Find the probability that a 5 is first obtained in fewer than 10 throws. This is the formula of fewer than 10 throws. Like probability x less than 10 is 1 minus q power 10 minus 1, which is 9. So with the help of this formula, we can get this probability. Q is 5 upon 6. So this is the answer up to 3 significant figures. Question number 2. This question is of normal distribution. The weights of bags of sugar are normally distributed with mean mu 1.04 and standard deviation is unknown. In a random sample of 2000 bags of sugar, 72 weighed more than 1.10 kg. Now this information means probability x greater than 1.10 is 72 upon 2000. This is here. So we need to convert this statement from x into z with the help of this formula, x minus mu over sigma. So after converting the statement from x into z, we have this thing, and this number is 0.036. Since we have greater sign, so we need to shade this area from right to left, this area. This question is of inverse normal, and this area is this. Since total area is 1, therefore this area is 0.964. So by taking phi inverse of this number, we have this value of c. So this is equal to 1.798. 1.10 minus 1.04 on sigma is 1.798. By solving this equation for sigma, we can get the value of sigma up to 3 significant figures. In this question, the most important part is shading of this area. Make sure you must shade the correct region according to this sign of inequality. Whenever we have greater sign, we shade area in this way. Next question, number 3. On each day that Alexa goes to work, the probabilities that she travels by bus, by train, or by car are this, this, and this. So by bus, by train, or by car. When she travels by bus, the probability that she arrives late is 0.55. This is here. By train, the probability is 0.7, and by car, the probability is x. So this should be 0.45 because total is always 1. This should be 0.3 and this should be 1 minus x. Late, not late. On a randomly chosen day when she goes to work, the probability that she does not arrive late is 0.48. So does not arrive late means this or this or this. So sum of all these three will be 0.48. So 0.4 times this is here, 0.35, 0.3 is here, 0.25 times 1 minus x is here. Make sure you use bracket for this when you will multiply 0.25 with this, like this. So x is 0.22. This answer is exact, so there is no need to give this answer up to 3 significant figures. Part B. Find the probability that she travels to work by train given that she arrives late. This probability means she does not arrive late. So probability for late should be 1 minus this, which is 0.42. Find the probability that she travels to work by train given that she arrives late. So this should be the this should be the numerator, train, late, and this should be the denominator, probability late. This is here, and train and late, this should be here, and the answer should be up to 3 significant figures. Next, question number 4. A fair spinner has sides numbered 1 to 2. Another fair spinner has sides -2, 0, 1. Each spinner is spun. The number on the side on which a spinner comes to rest is noted. The random variable x is the sum. Now this information is important. X is the sum of the numbers for the 2 spinners. So by using the possibility space diagram, we can easily get the possible values of x. This is the possibility space diagram, and the operation is addition. So 1, 2, 2 is here, and these numbers are here. We just need to add them. -2 plus 1 makes -1, -2 plus 2 makes 0, and so on. So these are the possible values of x. So x can take -1, 0, 1, 2, or 3. These values are here. And the probability of -1 is 1 upon 9 because we have 9 numbers, and probability of 0 is 2 upon 9, probability of 3 2s is 3 upon 9, 1 is 1 upon 9, and 3 is 2 upon 9. So this is the way to construct the probability distribution table for this situation. Now we need mean and variance. Mean is very simple, we just need to take the sum of the product of these numbers. -1 times this is here, 0 times this is 0, so 1 times this is here, this is here, and this is here. The answer is 4 upon 3. For variance, we first need to find ex square, because the formula of variance is this. Ex square minus square of mean. For ex square, we need to square this first, and then we need to multiply the answer with this. So -1 square is 1 times 1 upon 9 is this. This is 0, so 1 square times this is 1 upon 9. 2 square is 4, 4 times this is 12 upon 9. This is 9, 9 times 2 is 18 upon 9. And square of this is 16 upon 9. That's the final answer. If the answers are in fraction, you can leave your answers as it is. There is no need to give the answer in 3 significant figures. These answers are better than the estimated answers, because these answers are exact answers. Next question. Every day Richard takes a flight between A and B. On any day the probability that the flight arrives early is this, on time is this, and arrives late is this. Part A. Find the probability that on each of three randomly chosen days his flight does not arrive late, meaning on. Does not arrive late means on time or before time. So probability of late is 0.3, does not arrive late means 0.7. So L complement, L complement, L complement. On three randomly chosen days, his flight does not arrive late. So L complement first day, L complement second day, L complement the third day. So 0.7 power 3 will give you the answer. Find the probability that for 9 randomly chosen days, this situation is of binomial with n9 and early, so probability P is 0.15. At least 3 times. At least 3 times means this thing. Three, 4 till 9. Since this method is lengthy, so we need to use the indirect method, which is 1 minus 2, 1, 0. Those numbers which are not in this list, and this is here, 2, 1, 0. And give your answer up to 3 significant figures. Next part of this question. Part C. 60 days are chosen at random. Use an approximation. Approximation means normal approximation, to find the probability that his flight arrives early at least 12 times. So this is a binomial situation. Early means 0.15 and 60 is n. Now we have to convert this into a normal distribution form, and for that we need to find NP. So NP is 60. NP is 9. 60 times 0.15 makes 9. And NPQ is 7.65. So first find NP and NPQ, and then use number line for the continuity correction. We need this probability. So the first number on the line should be 12 because this number is inclusive. Whenever we go on right side, we always take the lower bound. So the lower bound of 12 is 11.5. So this is the way to convert this statement from x into z. 11.5 is here, NP is here, and NPQ is in root. So we need this area, 0.9039. So we need this area, so this area is 1 minus 5, which is 0.183. Make sure you do the continuity correction correctly, and for continuity correction, number line is the best way. Since this number is inclusive, so write this number here, and since we are going on right side on the number line, so we need to take lower bound, and make sure you use root for this number. You have to show under root here, and give your answer up to 3 significant figures. Next question. 6a. Find the total number of different arrangements of the 8 letters in the word tomorrow. So this is so simple. There are 3 O's and 2 R's. So 8 factorial for all, and 3 factorial is for 3 O's, and 2 factorial is for 2 R's. So these are the total number of ways. Part B. Find the total number of different arrangements of the 8 letters in the word tomorrow that have an R at the beginning and an R at the end, and in which the 3 O's are not all together. This statement is very important. Are not all together. And always use box method to solve this type of question. And first find the options in which O's are together, and then subtract this option from total to get not together. So when all 3 O's are together with R's at the ends, See, R are the at the ends, and these three O's are together. These are the three remaining letters. So this is one object, second object, third object, fourth object. So we have altogether four objects. So we just need to write 4 factorial for this. So this is the way to find the number of arrangements in which R's are at the ends and all three O's are together. 4 factorial. Now we have to find the total in which R's are at the ends and these letters are random. So there are 6 letters. So 6 factorial and 3 O's, so 3 factorial. So this is total. So we need to subtract 4 factorial from this to get the not together options. Total minus together. So there are 96 ways. So whenever you have this type of question, first find together through box method and then subtract this from the total. Next part of this question. 4 letters are selected at random from the 8 letters of the word tomorrow. Part C. Find the probability that this selection, now this is important. Now, find the probability that this selection contains at least one O and at least one R. So, if we have to find probability when letters are repeated in selections, then we have to consider the selections of repeated letters as well. Normally, we don't consider the selections of repeated letters. Let's suppose we just need to select one letter O from 3 O's. We never write 3C1 if the question is only for selections. For unique selections, we never mention this thing. But for probability, we have to mention this thing. Why? Because all 3 O's have equal chance of selecting or occurring in probability. For example, if we have these 3 letters, and if I ask you find the probability that if one letter is selected at random from these 3 letters, find the probability that the letter is A. So you will do this in this way, 2 upon 3. And this means 2C1 over 3C1. So basically, when we solve questions of probability and when objects are repeated, we do consider the selections of repeated letters. And we do mention combinations for those letters. I use 2C1 for 2 A's. I need 1 A from these 2 A's, so I mention 2C1 here and 3C1 here. This example will help you to understand this concept. So we do use NCR for the repeated letters in probability. For example, if we have these 3 letters A, A, B, and we are selecting one letter, find the probability that the letter is A. So you will write 2 upon 3, and 2 up means 2C1 and this means 3C1. See, we have 2 A's, so we can have any A from these 2, so 2C1, and there are 3 letters, so 3C1. So make sure when the question is of probability in selections, then must write or must use NCR even for repeated letters, because both the A's have equal chance of occurring. That is why we mentioned 2C1 here. Now coming back to this question, find the probability that the selection contains at least one O and at least one R. So we have to consider all possible ways of selecting or finding the probability of 4 letters. So 4 letters with this condition, at least one O and at least one R. So the first option is 1O and 1R. You have to mention the selection of 1O, which is 3C1. This is what I was explaining here. Must use C even for repeated letters in probability questions, because there are 3 O's and all these 3 O's have an equal chance of occurring. So that is why we mentioned 3C1 here, as we did here 2C1 for 2 A's. So 3C1, then there are 2 R's, so 2C1. Now we need 2 more letters, because altogether we need 4 letters, so 3C2. So there are 18 ways. Now selections with 1O, 2 R's and 1 other letter. So for 1O write 3C1, for 2 R's write 2C2, and for 1 remaining write 3C1, because there are 3 remaining letters. We can have anyone from the remaining 3. Now selections with 2 R's when 1 R, 2 O's and 1 R. So for 2 O's write 3C2, for 1 R write 2C1, and we need 1 more from remaining 3, so 3C1, 18 ways. Now selections with 3 O's and 1 R, so 3 O's, 3C3 and 1 R, 2C1, so 2 ways. 2 R's, 2 O's and 2 R's, so 3C2, 2C2, so there are 3 ways. So altogether we have 50 ways. And total is 8C4, because we need 4 letters from 8 letters. And the final answer is 5/7. This question is very important. So we always use combinations even for repeated letters if we find probability, because all the repeated letters have equal chance of occurring. You can take the screenshot of this solution if you want, because this question is very important. Last question of this paper. 7. The heights in centimeter of the 11 basketball players in each of the 2 clubs, the Amazons and the Giants, are shown below. Part A. State an advantage of using a stem and leaf diagram compared to a box and whisker plot to illustrate this information. The best advantage of stem and leaf diagram over the box plot is that stem and leaf diagram shows all the data. It shows all the data. The original data has retained in stem and leaf. Part B. Represent the data by drawing a stem, back-to-back stem and leaf. This is so simple. We have to keep Amazons on left side and G are on right side. So the smallest observation is 175 and the highest observation or largest observation is 215. This is the smallest observation and this is the largest observation. So the stem should be between 17 to 21. So 17, 18, 19, 20 and 21. And this is the stem and leaf diagram. 175 write 5 here, 182 so 2 here, 184 4 here, 187 7 is here, 189 9 is here and so on. And you have to mention the key. Make sure you must mention the key. So we are mentioning the key with the help of these two information. You can use any two informations, this or this. So first explain this thing. So 181 means, this 181 means 18/1 means 181 centimeter for Amazons, and this 18/2 means 182 centimeter for Giants. Next part. Find the interquartile range of the heights of the players in the Amazons. This is so simple. Since the data is odd in number, 11, so we need to use this formula of Q. 1 upon n plus, this is in fact 1 upon 4 n plus 1th observation. This is the formula of Q1. So n plus 1 upon 4th observation. So n plus 1 is 12 and upon 4 is 3rd observation. So 3rd observation, this is 1st, 2nd, 3rd, this is Q1. 182. and Q3 is the ninth observation, so it should be 1, 2, 3, 4, 5, 6, 7, 8, 9. This is Q3, 202. So IQR will be the difference of these two, which is 20. Next part of this question. 4 new players join the Amazons. The mean height of the 15 players in the Amazons is now 191.2 centimeters. So this is the mean of 15 players. The heights of the 3 of the new players are this, and this. Find the height of the 4th new player. This is so simple. First, we need to find the sum of these numbers, these 11 numbers. So sum of the 11 numbers with these 3 numbers is this, 2132. Sum of the 11 numbers is 2132. Right? These 11 numbers. Now we need to add these 3 numbers into this sum. And then the height of the 4th player, we need to add height as x, or you can use h, you can use anything. So this is the height of the 4th player, the missing player. And these 3 numbers are here. So this is the sum of 15 numbers, 15 players. So we need to divide this by 15 and equate to this mean. Hence the height of the 4th player is 181. So first find the sum of 11 players, height of the 11 players, then add these 3 numbers with the 4th person's height as x. So this is the sum of the 15 players. Now divide this sum by 15 and equate this to 191.2 to get the height of the missing player, the 4th player. Well, this is all. An important advice for me and for everyone: we must be honest. All the best. Allah Hafiz.